Hi guys, a very good morning, afternoon, and evening to wherever you are watching this from. Today we are going to be starting a new lecture on cubes and cube roots for class 8 ICSE. Okay, even if you are from a different background, if you want to learn about cubes and cube roots, I think this this is going to be the perfect lecture for you to figure out what is the basics of this particular chapter that we are going to be starting off. Okay, so as the name of the chapter suggests, cube and cube roots. Before starting off the cubes and cube roots, we also have a knowledge about square and square roots. That was the previous lecture. If you have any doubts in that particular chapter, feel free to watch the previous video before starting off with this one. Okay, Chalo, let's begin, guys. Okay, so what are we going to be learning in this particular cubes and cube roots in our daily life? One second, guys. I think there is some problem with the network. Let me get that fixed first. Okay. Okay, guys. So, what are the things that we are going to be learning today? We're going to be learning why do we need cubes and cube root in our daily life. Introduction, what is that actually? Perfect cubes, cube roots, examples and practice, and at the last, this is a synopsis. Like what do we learn? A culmination of the chapter. Okay, so let's begin. See, first example, volume of 3D objects. Imagine, like I will read from the board what is written, then I'll give you an example. Imagine you're buying a cube-shaped box for storing your belongings. If you know the length of one side of the box you can use is a cube to calculate its total volume. So, if I am going to, okay, like we all know what is the volume of a cube. Volume of a cube is nothing but a cube, right? So this cube that is stated here is nothing but like the a raised to the power 3. That is nothing but if we draw a cube here. If I draw a cube here, okay, if this side, each of the sides are, let me annotate this. If each of the sides are A, and A, so length is equal to A, breadth is equal to A, and height is equal to A, as volume is nothing but length into breadth into height, we are going to be getting A into A as all of the threes are same. Thus, we get the answer as A cube. This A cube is nothing but A, the each side multiplied by 3 times. That is nothing but a cube. Okay, I hope you understand this. Okay. So it is useful for many particular reasons, but the main reason of studying this is because we can do this directly. This is just a basic example. Okay, next, construction and architecture. In everywhere, if you want to find out the volume, okay, like same cheese. In case here, it's like they want to find the formula for a cubic tank. So cubic tank will be using, right? One second, guys. Okay, so in case we want to be, so the cube theory can be also explained in case of constructions in architecture. Let's move towards the next one. Next is scaling objects. Okay, now how, what is that scaling? If you are designing a scale, for example, I have done a scale in which 1 centimeter is equivalent. This is very useful in case of, what do you say, distance. Okay, like I draw a map of a place. For example, this is a location, any particular island you can think about. So this entire place I've written here. It is written particularly in this direction. This is entirety is 5 centimeter. And here I'm going to write 1 centimeter is equal to 1000 kilometers. Okay, so 5 centimeters is nothing but in actuality 5 centimeters is nothing but 5000 kilometer. Okay, so this can be also written as 5 into 10 to the power 3 kilometer scale. So here 1 centimeter is equal to 10 to the power 3 kilometer. This is the scale that we are talking about. Okay, let's move forward. So cube root in agriculture, same thing. If you have 125 cubic meters of the soil, the cube root of the soil is 125. So cube root of 125, cube root of 125 is going to be nothing but 5. So this, what is cube root, the videos, everything about the basic concepts will all be covered in this chapter. These are just the example. Why do we need this in daily life? Okay, so this particular thing is very important. Okay, I strongly believe that we have to memorize this till 20 squares and cube should be memorized. Okay, I will be saying this again. 1 cube is 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 512, 9 cube 729, 10 cube is 1000. 11 cube is 1331, 12 cube 1728, 13 cube 2197, then 14 cube 2744, 15 cube 3375, 16 cube 4096. See, this this first 10 is very easy to memorize. This we have done or we will be doing sums about. But this last 10 are going to be like we need regular practice, nothing else. Okay, we don't need to memorize for this because we all know, right? Okay, so this cube, if you want to find out what cube is, we are going to be doing this 19 cube. Okay, so 19 cube, there is a basic step, but I'm not going to be doing any shortcuts in this particular lecture because we need to understand the basic concepts of what is happening. So 19 cube is nothing but 19 into 19 into 19. So 19 square we can do, or we can do 19 to 19, 19, 19 again and again. So we can find out the answer that is going to be coming out at 6859. Okay, chalo. Now let's begin. Now there is a video on adding consecutive odd numbers and difference between cubes and consecutive natural numbers. We have done what are the difference in case of squares. We have also found this out, right? So let's do this in case of a cube. Okay, let's watch the video and see what is this about.
In the previous video, we have seen what are perfect cubes. Now let's see if there's any relationship between perfect cubes and odd numbers. Here we have the cubes of numbers from 1 to 5. 1 cube is 1 itself. 2 cube is 8. We can express this 8 as the sum of odd numbers 3 and 5. 3 cube is 27 and can also be represented as the sum of odd numbers 7, 9 and 11. Similarly, we can represent the remaining cubes as the sum of odd numbers. Now, is there any pattern here? Yes, the first cube number is 1, which is the first odd number. The second cube number 8 is the sum of the next two consecutive odd numbers 3 and 5. The third cube number is 27, the sum of the next three consecutive odd numbers 7, 9 and 11. And this goes on. So in this way, we can represent perfect cubes as the sum of consecutive odd numbers. Now, consider the difference between cubes of two consecutive natural numbers. For example, 2 cube minus 1 cube. We get the difference as 7. Now, we can express this 7 as 1 plus 2 into 1 into 3. Why should we represent 7 in such a manner? Let's understand this. Observe that by writing it in this fashion, we can form a pattern here. 2 cubed minus 1 cubed can be represented as 1 plus the first number, which is 2, multiplied by the second number, 1, multiplied by 3. Similarly, we can represent the difference between the cubes of the next two consecutive natural numbers as shown. So in general, for two consecutive natural numbers n and n plus 1, we have n plus 1 the whole cube minus n cubed equal to 1 plus n plus 1 into n into 3. Now by applying the same pattern, can you find 51 cubed minus 50 cubed? Do share your answers with us in the comment section below. We hope that you've enjoyed this video. To learn more about cubes and other interesting concepts, do visit our website.
Okay guys, I think this particular video is done. So let's go to the next phase. So another video, see this particular chapter, me explaining every concept, explaining everything, it's better you watch the video because that is very important because they're going to be saying that in a well structured manner rather than if there is something that I realize, okay, watching the video you cannot understand well, so I'll be explaining that same part again. Okay, now let's focus on the next portion of the class, that is how to find out the smallest multiple that is a perfect cube. Okay.
In the previous videos, we have understood the meaning of a perfect cube. Now, is 216 a perfect cube? Let's check. By prime factorization, we can write 216 as shown. Now observe that we can group the factors in triples. Here, factors 2 and 3 appear 3 times each. Hence, we can write them as 2 cube and 3 cube. Now we know that a raised to n into b raised to n is equal to a into b the whole raised to n. Hence, we can write 216 equal to 2 into 3 whole cube or 6 cube. Thus, 216 is a perfect cube. Now, is 500 a perfect cube? Let's find out in the same way. The prime factorization of 500 is as shown. Now observe that we can represent only 5 in terms of the cube, but not 2 since we don't have 3 2's. So, 500 is not a perfect cube. Now, can we multiply 500 with some number to make it a perfect cube? Yes, we can. If we multiply both sides by 1 or 2, then we can easily represent the resulting number in terms of cubes. Hence, the smallest natural number by which 500 should be multiplied to make a perfect cube is 2. Now, consider 1029. Let's find out its prime factors. In the prime factorization of 1029, we see that only 7 can be represented in terms of a cube. Hence, 1029 is not a perfect cube. Now we can multiply 1029 with 2 3's to make it a perfect cube. But there is another way of converting 1029 into a perfect cube. Can you guess? Yes, we can divide 1029 by 3 and make it a perfect cube. So let's divide here. On dividing 1029 with 3, we get 343, which is equal to 7 cube. So 343 is a perfect cube. Hence, the smallest natural number by which 1029 should be divided to make a perfect cube is 3. And with this, we've number into a perfect cube by multiplying and dividing it with the smallest natural number. We hope that you've enjoyed this video. To know more about cubes and other interesting concepts, keep learning with Don't Memory.
Okay, guys, now see what is there next. We have done this. Now, what is the cube of a number? Finally, we have understand all the sides and attributes of what is this. How do we realize that what are the different numbers between two cubes? What are cubes? What? How can you define what number you have to multiply it to make sure it is going to be a cube? What number you have to divide it to make sure it is a perfect cube? Okay. Now we'll understand what is the cube of a number. Very basic, very easy. Okay. Let's give it a shot. This is a very basic video, guys. You can watch it in 2x speed as well, wherever you have it. Okay.
This video on cubes is very similar to the one on squares. If you understood the concept of squares, the concept of cubes will be stress-free. Let us get to the basics first. Look at this number on the board. It's read as 7 raised to 3. And raised to 3 is called cubed. So the number can be called 7 cubed. Why do we have a distinct name for raised to 3? Well, it's the same reason as to why we have a distinct name for raised to 2. It's because raised to 3 has many applications. Here is one of the practical examples. Assume we have a box in the shape of a cube. Assume the length of all its edges equal 3 centimeters. If we remember correctly, the volume of a cube is given by side multiplied by side multiplied by side. So that will equal 3 multiplied by 3 multiplied by 3. So this is actually 3 cubed. That will give us 27. So that's one of the practical applications of cubed or raised to 3. But wait, are we forgetting something? Yes, it's the units of the answer. So the units of each side are also multiplied to get centimeters cubed. That's the precise answer. The volume of the cube is 27 centimeters cubed. The answer is also written as 27 cubic centimeters. So we can see that when 3 lengths are multiplied, we utilize the concept of cubes. Let's understand another straightforward example. So 10 centimeters multiplied by 9 centimeters multiplied by 6 centimeters. Multiplying the length gives us 540. We did not use the concept of cubes here as we have 3 different numbers. But multiplying the units gives us centimeters cubed. So the answer can also be written as 540 cubic centimeters. So whether it's squared or cubed, the units also differ accordingly. Now there's a vital property we need to understand. To understand the property, here are a few examples. How do we find the value of 7 cubed? It is 7 multiplied by 7 multiplied by 7, and that equals 343. Minus 14, the whole cube equals minus 14 multiplied by minus 14 multiplied by minus 14. That equals minus 2744. And similarly, 18 cubed equals 18 multiplied by 18 multiplied by 18, which equals 5832. Observe the sign of the number and the sign of the answer. If negative, then negative. If positive, then positive. So we can say that for cubes of numbers, the sign of the answer is same as the sign of the number. That is, cube of a negative number will result in a negative number, and the cube of a positive number will result in a positive number.
Okay, we have covered that particular part out. Okay, so let's head on to the second question. Now, for any number, let us hold for the number be m. Okay, so m is called the cube of m or m cube and is written as m raised to the power 3. Okay, so again, cube of 5 is 5 into 5 into 5, this is 125. Cube of 8, 8 into 8 into 8, 512. Cube of minus 4 into minus 4 into minus 4, minus 64. See, in case of squares, we have understood, in case of squares, we have understood that there cannot be any negative squares. Okay, there cannot be negative squares, but in case of cube, there can be negative cubes. Why? Okay, so if I have this cube of minus 3, so minus 3 into minus 3 into minus 3. Okay, so minus 3 into minus 3 will give us what? Plus 9. Plus 9 into minus 3 will give us minus 27. Okay, so minus sign, negative cubes are possible, but negative squares are impossible. Okay. Okay, now how to solve each and every step sums, not only in this particular chapter but in every particular problem in mathematics. First we have to identify the problem, then we have to separate it, then we have to solve it step by step, and thus we'll get our answer. Okay, so perfect cubes, we have already figured what perfect cubes are, right, from the last videos. So if a particular number is going to be divided, or by prime factorization method, we are getting out all the values that are same, that way we can tell that this particular number is a perfect cube. Okay, so let's define it. So let's do it for this 15. So 15 cube is getting 3375. Okay, so let's write here 3375. Okay, first let's start off with the lowest particular number, so that is 3. So 3 plus 3, 6 plus 12, so 3. This will be 1, 1, 2, 5. Let's see whether this is divisible by 3 or not. 5 plus 2, 7, 8, 9. So yes, divisible by 3. 3 threes are 9. Then 10, 11, 21, 7, 5. Now let's see if this is divisible by 3 or not. 3 plus 7, 10. 10 plus 5, 15. The 15 is also divisible by 3. So 125. Now this is divisible by 5. 25. Again divisible by 5. 5 divisible by 5. 1. Okay. So we have 3 into 3 into 3 into 5 into 5 into 5. Okay. So in case of squares, we will pairing number with 2 pairs. But in case of cube, as the name suggests, we are going to pairing it by 3 groups together. So 3 into 5, the answer comes out to be 15. Okay, so thus 3375 is a perfect cube. Next, let's do some practice. Okay, before starting off with the practice, we have another video, that is the second part of the chapter, that is smallest multiple, that is a perfect cube. Okay, let's watch the video. Smallest multiple, oh, that is already done. This particular video is already covered, so no point seeing this. Let's do the sums. Okay, chalo. Is 297 a perfect cube or not? Okay, let's see. You're writing here 297. It is, the unit digit is not even, so it is not going to be divisible by 2. Let's try out 3. So 9 plus 2, 11. 11 plus 7, 18. Okay, it is doing it divisible by 3. So uh, 3 nines are 27. Again 9. 3, 33. 3, 11. Okay, so we are getting 3 into 3 into 3 into 11. So this is okay, this is going to come, so this is going to be coming out, but here this particular portion is not coming out. It's not a perfect cube. If you're multiplying it by 121, then only it will become a perfect cube. Okay, so the number 297 is not a perfect cube. Okay, now let's find out for 2744. So 2744 divided by 2. Last number even. So let's start off with 2 only. 1, 3, 7, 2. Again even. Divided by 2. 6. 8, 6, again by 2, 3, 4, 3. Now this 3, 4, 3, let's find out what is divisible by. I can relate to it because I have memorized all the cube. So 3, 4, 3 is nothing but the cube root of 7. So 7, 49, 7, 7. So we are getting this as what? 2 into 2 into 2 into 7 into 7 into 7. Now let's make it a pair of 3. Sorry, in groups of 3, pair is 2. So we are getting 2 into 7 and the answer is 14. So thus this is a perfect cube of what? Of 14. Okay, so not a perfect cube, a perfect cube. Now let's go to the next portion. What is the smallest number by which 3087 should be multiplied so that the product is a perfect cube? Okay, chalo, let's do this. Smallest number by which 3087 should be multiplied. Okay, again we'll take nothing but 3087. Let's divide this by 3 because as I can see 18, if we add all the digits it's coming to be 18. So divided by 3. 1, 0, 2, 9. Again divisible by 3 because 9, 10, 11, 12. Okay, so 3, 12 comes out to be 4 and this is 3. So again 7, 49, 7, 7. Okay, so 3 into 3 into 7 cube. Okay, so what is the smallest number by which should be multiplied? So we have to multiply. As we can see, if we are multiplying it one more 3, then 3 cube is going to come. Then the number will become 7 cube into 3 cube. So we need what? We need one more 3. So the required answer is 3. Okay, I think this is very easy. Let's see what the answer states. Okay, so 3087 must be multiplied by 3 in order to make it a perfect cube. Okay, now what is the least number by which 6750 should be divided so that the quotient is a perfect cube? Okay, let's find out. So I have 6750. So as the last digit is even, so we are going to start off with 2. So 2, 3, 3, 7, 5. Okay, this is okay. 3, 3, 7, 5. Let's go with 3 now. 3, 1, 1, 2, 5. Again with 3, 3, then 7, 5. Again with 3, 1, 25. Then with 5, 25, 5, 5. So after doing it, dividing it using prime factorization method, we are getting 3 cube into 5 cube into 2. So in the question it is saying what should be divided. So here if I divide this by 2, this and this gets cancelled out and this becomes a perfect cube. Okay, so the number here, least number here, is nothing but 2. Okay, I hope you understood this. Okay, divided by 2 in order to make it a perfect cube. Okay, so cubes of odd natural numbers are going to be odd. Okay, so let me tell you something. Okay, if let's take two numbers, so odd into odd. Okay, okay, let's see, 3 into 5, 50. So when we are multiplying odd numbers, odd number of times, we will get an odd number only. But odd into even will get us an even number. Odd into odd will give us what? Odd numbers. Odd into even numbers. Okay, and even into even will always give us even numbers only. Even into even will give us even numbers only. Okay, I think this is Very practical, you can try to do it with any numbers and you want to multiply it. So cubes of every natural numbers are even. Cubes of even natural number are going to be even. That's it. Okay. Why? Let me show you. If I take 2 into 2 into 2. Okay. 2 into 2 4. 4 into 2 8. As I've already stated that even into even will give us nothing but even only, right? So this both are even. So even into even again will give us even. This is 8. Okay. Check. Next portion. Now another sum. A cube has a side length of 8 centimeter and another cube has a side length of 6 centimeter. Okay. So the first cube has side length of 8 centimeter. Let us draw that cube. Okay. So I have one cube of side 8 centimeter and another cube of side 6 centimeter. Okay. How much more volume does the first cube have as compared to the second? Okay. Let's calculate the volume of the first cube. Volume of first cube will be 8 cube, that is 512 centimeter cube. Now volume of the second cube will be 6 cube, that is 216 centimeter cube. Now how much more volume? More volume, so we have to find the difference. So difference is going to be 512 minus 260, 161, 10, 9, 4, 2. So 296 centimeter square. Okay. So this is the how much volume it is more. If we want to give this answer in percentage, we can write percentage more is equal to 296 divided by compared to the second, the second portion. So that second portion will be in the denominator into 100. Okay. Now let's try to solve it. So 148, 256, 74, 128, 37, 64. Then this is 32, 50, 16, 25. So 37 into 25 divided by 16. This is divided by 2. We are getting 8 divided by 2. 12.5 divided by 2. 4 divided by 2. 6.25 divided by 2. 2 divided by 2. 1. This is 18.5 divided by 2. 9.25. Okay. So 9.25 into 6.25. Let's do it. So 925 into 625, 5, 25, 10, 12, 45, 46 into, let's write it here, 2 5s are 10, 1, 4, 5, 2s are 18, 5, 2, 6, 4. Last is this is 3, 30, 12, 13, 14, 15, 1, 45, 54, 55. So 5, 2, 1, 1, 4 plus 6, 18, 1, 6, 7, 5, and then 1, 2, 3, 4. So 57.81%. Okay. This is the answer if we want to find out using percentage. Okay. Take your time, understand this, but I think this should be enough. 296, because here nothing as percentage is mentioned. Okay. Let's move forward. Okay. See, no percentage is mentioned. So the answer comes in the first instance 296 centimeter cube. Now let's go to the next sum. The volume of a cube is given by V is equal to x's cube. Okay, where x is the side length. If the volume of a cube is 125 centimeter, find the value of x. Very simple. You already know how to solve this. So they have given the question only. So volume is equal to x's cube. Okay. So here it is given 125 is the volume is equal to x's cube. Okay. So root over 125 is equal to x. Okay. So 125 divided by 5, 25 divided by 5, 5. So this is nothing but 5 cube. The value of x will be 5, 3 into 1 by 3. That is nothing but 5. Okay. The value of x will be 5. Okay. I think this is very easy to understand. Now, next sum. Two cubes have side lengths of 6 centimeter and 4 centimeter. Find the difference in their volumes. Again, similar type of sum we have just solved. The first cube, volume of first cube is nothing but 216 centimeter cube. Volume of the second cube is nothing but 64 centimeter cube. Difference. So V1 minus V2 is going to get us what? Centimeter cube will be the unit here. So 2, 1, 5 and 152 centimeter cube. Okay. This particular chapter has sums that are very easy to understand. Okay. So first volume of the first cube, volume of the second cube, difference. Next, cube roots. Okay. So what is the cube root of a number? We have a video pertaining to it. I hope you understand the video. So let's play. We have two more videos after this. So let's begin, guys. What is cube roots?
By now, all of us know how to find the cube of a number. So 3 when cubed gives us 27. It means 3 multiplied by 3 multiplied by 3 equals 27. So what is a cube root? Well, the cube root of 27 is 3. That's all. This is the most important concept of cube roots. The rest of the video will just focus on how cube roots are denoted and its application. So remember, 3 cubed is 27 and cube root of 27 is 3. Well, this is how the symbol of a cube root looks like. A root sign with a 3 here. So we can say that the cube root of 27 is 3. And as we saw in the square root video, this root sign is called the radical. And the number inside it is called the radicand or the base. Here's a better way to understand the concept of cubes. 4 cubed equals 4 times 4 times 4, which equals 64. We all know this. This 3, when taken to the other side, becomes cube root. Hence, we can say that the cube root of 64 equals 4. Now, we're on our way to understand a very interesting concept. We will try to understand this concept with just one example. We know that cube root of 64 is 4. This example looks very simple, but modifying it slightly can make it interesting. Let's play with these numbers. We can write 64 as 2 raised to 6. Hence, cube root of 64 can be written as cube root of 2 raised to 6. We can also write 64 as 4 cubed. Hence, we write this as cube root of 4 cubed. Now let's try writing 4 in an exponential form. 4 can be written as 2 squared. Hence, this would equal 2 squared. And of course, it can also be written as 4 raised to 1. What do we observe? Yes, when we take the cube root of a number in exponential form, the base remains the same and the exponent is divided by 3. 6 became 2 and 3 became 1. Remember, when we take the cube root of a number in exponential form, we should keep the base same and divide the exponent by 3. Let's quickly look at a couple of examples. Say we want to find the cube root of 4 raised to 9. The base actually equals 262,144. Imagine finding the cube root of this big number. But using our technique, all we need to do is keep the base same and divide the exponent by 3. Here the base is 4. Hence we write a 4 here and divide 9 by 3. Hence we get the cube root of 4 raised to 9 as 4 raised to 3. Now let's try finding the cube root of 7 raised to 6. We can write it as 7 raised to 6 by 3, which equals 7 raised to 2. So remember, keep the base same and divide the exponent by 3. In the coming videos, we will see how we can calculate the cube root of large numbers which are not in exponential form.
Okay, I think let's go to the next one. Now, multiplications of integers. How do we find this is a different video, not required. Okay, so the cube root of a given number is the number whose cube is given. Okay, so we have found out that x raised to the power 1 by 3 and cube root of x is actually the same thing. Okay, so cube root of 3 is 27, cube root of 27 is nothing but 3. Okay, sure. Now, how do we find the cube root of a number using the prime factorization method? We've already done this. I've been showing this. It's exactly the same as we have been using prime factorization method in case of finding squares and square root. It's the same method, but in case of a square root, we have divided the numbers in pairs of 2. Here we'll be making them a group of 3. That is the only difference. Okay, so how do you find the cube root of a number? Using prime factorization method. Let's give it a watch.
In the previous video, we learned how to find the cube roots of numbers in exponential form. But what if the numbers are large and are not in exponential form? Well, we use the prime factorization method. Say we want to find the cube root of 216. Our aim is to reduce this number to its prime factors. We write the number here and draw lines like these. Now we think of one prime number that is a factor of 216. We know that 2 is a factor of 216. So we write a 2 here and we divide 216 by 2 and write the quotient here. That is 108. 2 multiplied by 108 gives us 216. So we continue with the same procedure. We think of a prime factor that is a factor of 108. Well, 108 is also divisible by 2, and 2 multiplied by 54 gives us 108. Again, since 2 is a factor of 54, we write 2 here and write 27 here as 2 multiplied by 27 equals 54. Please note when we get a prime number here, 27 is not a prime number, and hence we continue with the same process. Now the prime number that is a factor of 27 is 3. So we write 3 here. 3 multiplied by 9 equals 27. And we know that 9 equals 3 multiplied by 3. This is where we stop. We stop when we see a prime number here. So we have reduced 216 into its prime 116, we group the 3 2s together and the 3 3s together. And from each group, we pick just one number and multiply them. So from the first group, we pick 2, and from the second group, we pick 3. And after we multiply them, we get 6. Hence, the cube root of 216 equals 6. So now we know that once we reduce the numbers to its prime factors, the task is very simple. We make groups of 3 and choose one number from each group and multiply them. And it's a good idea to memorize the cubes of numbers from 1 to 10. I'm talking about the cubes and not the cube roots. Why do I say this? It's because you'll be able to find the cube roots of large numbers in a matter of few seconds, maybe even 5 seconds. And when I say large, I mean numbers up to even 6 digits long. We will see that in coming videos. Keep watching and keep learning.
Okay. Now we'll be finding the cube root of 729. Okay. Chalo, let's begin, guys. So 729. Last digit not even, so let's start off with 3. 7 plus 2 9, 9 plus 9 is 18, so 18 is divisible by 3. So 243. Again by 3. Why? Because 2 plus 4 is 6, 6 plus 3 is 9. So 9 is divisible by 3. Yes. So 81. Again by 3. 81 is going to be divided only to 27. 3, 9, 3, 3. So let's count the number of 3's that are here. So 729 is actually equal to 3 into 3 into 3 into 3 into 3 into 3. 1, 2, 3, 4, 5, 6. Again, pairing 3 to the power 6. Now cube root is required, right? So cube root is required. So 3 to the power 6 into 1 by 3 to 3 square, and the answer is going to be nothing but 9. So the cube root of 729 is 9. Okay. Next, find the cube root of 1728. Let's do this. So I have 1728. Last digit is even. So 2, 8, 64, 2, 4, 32, 2, 2, 1, 6, 2, 1, 0, 8, 2, 54, 2, 27, 3, 9, 3, 3. Okay. So 1728 is actually 2 to the power 1, 2, 3, 4, 5, 6. To the power 6 into 3 to the power 3. Now we have to find cube root. So 3 power 6 into 1 by 3 into 3 to the power 3 into 1 by 3. This cancels out, this and this 2. So 2 to the power 2 into 3. So 4 into 3 comes out to be 12. Okay, that is the answer. Okay, let's continue. Now find the smallest number by which 210125 must be multiplied so that your product is a perfect cube. Let's begin. The number is 210125. Unit digit is not even, so let's start off with 3. 2 plus 1, 3. 1 plus 2, 3, 6, 6 plus 5, not divisible. So 4, not divisible. 5, let's go up with 5. 5. 5 4s are 20. 2, 0. 5 4s are 22. 0, 2, 5. Okay, let's see whether I did it correctly or not. 5 4 25, 5 10 11. Again by 5, 5 8s are 24 0 5. Again by 5, 1 5 6 7 8 30. This is 6 48 1. Now 9, this is going to be, so 5 is done, 6 is not going to be done, so 7. Let's check for 7. 7 divided by 1681, 2s are 14 minus 28, not divisible by 7. Let's check for, then what, then let's check for 8 is not going to be a value, 9 is going to be a value, 10 is not going to be a value, 11, let's check for 11. 11 1681, 11 ones are 11, 58 5 55, 5 6 7 8 31. Again not. Okay, so 11 is also not a value, 12 is also not going to be a value. Let's check for 13. 13 divided by 1681, 13 ones are 13, 13 3 38, 13 threes are 36 21. Again not going with 13. Let us rub whatever is not required. 5 fours are 22 0 2 5 5 8 8 24 0 5 5 1 6 7 8 6 8 1. Okay. Now as 15 is not even there, 16 not even there, let's try it with 17. 17 1 6 8 1. Okay, so 17 into 9, 63 9 10 11 12 13 14 15, 153. So 9s are 153, 3 5 6 7 8 so 5 151. So 17 is also not going. Let's go for 19. 19 into 7, 63 7 8 9 10 11 12 13 133 plus 19 12 145 152. If it's 152, the 119 is also not good. Okay, so 9 6 7 8 9. Okay, there is some issue. Let us see, let us try to do it in a different way. Chalo. So again let's start from scratch. So 2 1 0 1 2 5. Okay, it is going to be a perfect cube. So again by 5, this is 4 2 0. One second, let me do this. 2 1 0 1 2 5. 4s are 20 minus 10 2 10 1 0 2 2 5 5. Okay, so 4 0 2 5. Again by 5, 8 4 0 5. Again by 5, 5 ones are 5 6 7 8. That means 3 3 6 8 1. 1681. Let's see what are the value for 1681. Let's check it for another number. 19 was not there, right? So let's check for 23. 681. 23. 23 into 21 was also there, right? 21. 7 into 3. As it not multiple of 3, 21 is also not going to be there. 3 into 5, 15. 10 11 1 1 5 23 into 6, 18, 12, 13, 138. 138 to 13301. 23 into 6, so done. 7, 21, 15, 60, 161 to 161, 71, 83, 969. Okay, so we are coming close. 69. Okay, 1 second. Let me see what is the issue for this. Okay, the number here is nothing but 41. So we had to memorize this particular sum. Otherwise, there is one more thing of how to do this sum. So we have done all the first three steps, right? 1681 was present. Okay. So what can we do? 23 we have received this. So 23 I have realized that is the difference was last time 69. Okay, so what we can do to make the difference less, we will multiply it by 2. This is all assumption method. Okay, this is all assumption, so I don't like to go into assumption when we have something compact. So in this particular sum, for this particular sum, we have to be utilizing this only, where we have to do it by trial and error, because no one knows 1681 is going to be divided by 41 only, right? So this is sometimes the sum, even though you know everything, but still there will be some sums where you will be in a fuss. That is the reason why we already need practice. After recognizing the number, we can realize that, okay, this is going to be divided by 41 randomly. Okay, so cube root of a negative perfect cube, so minus m cube, we have already done this. Okay, so cube root can be minus. Okay, so these are all the examples of it. So cube root of minus 8, minus 8, minus 8 cube root, minus 8 is nothing but 2 to the power 3, but minus, so this will be nothing but 2 minus 3 into 1 by 3, giving us the answer is minus 2. That's it. Okay, same for the second one. Now there are some sums. Okay, the sums are very easy in case of this. So these are the two examples that we will keep in mind. So if you have understood exponents, this is the same thing that we have done in exponents. So if I have a number, for example, let's see. So both of them, this and this, both of them are perfect cubes. But in this one, you see, one is a perfect, like, in no one of them is a perfect cube, right? So what I will do, I will break this 54 into 2 into 27. As I'm breaking it 2 into 27, the 2 into 500 is going to be 1000 into 27. Now 1000 is a perfect cube, 27 is a perfect cube. Thus we get the number. Okay. So again, minus 6, 16 into 32. Similarly, 32 is 16 is a perfect square, not a perfect cube. So minus 8 into 2. So 8 into 64. Now it comes, this is a perfect cube of 2 and 4. The 2 in minus 2 into 4, that is minus 8. Similarly for the last two, 6 cube into minus 7 cube. So 6 into minus 7, that is minus 42. Okay. So again, a few sums, few concepts that we have understood. Okay, so this can be done only by practice. Let me give you some sum. Okay, so if I write here 216 divided by minus 512, and I write something like this here. Okay, so we all know that 216 is 6 cube, right? Divided by minus 8 cube. So this step converts into this. Thus we can write here, this is 6 divided by minus 8 or 3 by 4. Answer comes out to be 3 by minus 4. Okay. Now for the second one. Okay. So again, same thing here. we can give it like 500 into, what was the last one, 54 divided by 343, divided by 343. Now this is a cube. Something like this can come, right? First thing we will do, make sure these two are perfect cube. So 54, we are dividing it into what, 27 and 2. So we are getting what, we are getting 500 into 2 into 27 cube divided by root over 343. Okay, so root over 1000 into 27 over 343. That will give us nothing but 10 into 3 by 7. So 30 by 7 will be our answer if you are going to follow this method. Okay, similar to the last one, the reciprocal of it is going to be the same. Okay, these are all the examples. You can go through it. Whatever we have done, it is very easy and very understandable. Okay, last video of the day, how do we find the cube root of a large number in a very few amount of time? Let's watch this. I think I will also need to watch. Chalo, let's begin.
Now what you're going to see next may astonish you. You will learn how to find cube roots of larger numbers. That is, to 6 digits. Ah, come on, don't worry. And how long do you think it would take to find the cube root of a large number? If you focus hard for the next couple of minutes, you will be able to find the cube roots of large numbers in just 5 seconds. Yes, you heard me right. 5 seconds is all you will take to solve the cube roots of large numbers. Let's see a couple of examples. Assume we want to find the cube root of 2197. Now to get the answer in 5 seconds, there are 2 things you need to know. First, we need to know the cubes of numbers from 1 to 10 by heart. Here's the table of cubes of numbers from 1 to 10. In the first column, we have the numbers, and in the second column, we have the cubes of those numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. Second, we should know that for 4, 5, and 6 digit numbers, the cube roots will always be 2 digits long. Since 2197 has 4 digits, its cube root will also be 2 digits long. That's it. Only these 2 things. Cubes of numbers from 1 to 10, and the fact that large numbers which are 4, 5, or 6 digits long will have cube roots which are exactly 2 digits long. So let's move on. Look at this table for a moment and think. Is there anything that stands out? Pause the video and think for a moment. This is what you should have observed. Look at all the unit digits of the numbers in the cubes column. They are all different from each other. All numbers from 0 to 9 are covered. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Knowing this fact will help you understand the first step in our method. Okay, now we're all set to go. The first step of our method is to look at the units digit of the number. The units digit of 2197 is 7. So we look at our table. In the cubes column, we look for a number which has its units digit as 7. It's this one, 27. So we take the number from the first column corresponding to it and write it in the units place of the answer. The number corresponding to 27 is 3. So we write 3 here. So the first step directly gave us the units digit of the answer. Remember, the answer is the cube root of 2197. The next step is interesting. We ignore three digits from the right of the number. So we ignore 197 for the moment and look at the number that remains. It's 2. This number is very crucial. We check where 2 is placed in the cubes column. That is, we check the position of the remaining numbers in the cubes column. In the cubes column, the number 2 lies between 1 and 8, between these two numbers. That means it is placed between 1 cube and 2 cube. We basically looked at the corresponding number column. The last step is very important. Now that we know where it is placed, we choose the lower number in the corresponding number column. The lower of 1 and 2 is 1. That's it. This is your tens digit. So cube root of 2197 is 13. Remember, we always choose numbers from the first column, which is the numbers column, to write the digits of our answer. 3 was chosen from here and 1 was chosen from here. This looks really long at the first look, but with practice, trust me, you'll be able to solve it in 5 seconds. Now let's solve another problem so that you understand better. Say we want to find the cube root of 195,112. This number is 6 digits long and hence its cube root will be 2 digits long. Remember, cube roots of large numbers which have 4, 5 or 6 digits will always be 2 digits long. Now let's see the units digit of the number. It's 2. In the cubes column, we look for a number which has its units digit 2. Yes, it's 512. And the corresponding number in the numbers column is 8. So we write a 8 in the units place of the answer. Now we ignore 3 digits from the right, that is 112, and what remains is 195. Now where is 195 placed in the cubes column of the table? It is placed between 125 and 216. That is, it is placed between 5 cubed and 6 cubed. So from the numbers column, we choose the lower number among 5 and 6. It is 5. And we write this number in the tens place of the answer. Hence, the cube root of 195,112 is 58. With good practice, you will be able to solve this in 5 seconds. And remember that this method is a shortcut and cannot be used to solve questions in your exams. You may use this method purely to verify your answers.
Okay, so this comes to the end of our class today. So we have learned everything there is to know about how to find cubes, what are cube roots, how do we find cube roots using prime factorization, what is the assumption method, how did we find all the cubes. Okay, last video that shows this perfectly well. Okay, chalo, thank you for your time. I hope you had a good session. If you have any doubts or any issues, please let us know. Thank you. Have a great day. Bye bye.